So in 5.1, we're going to learn about classifying triangles by their angles and sides. And then we're going to find the measure of interior and exterior angles of triangles. So this first part is a bunch of terms, so we can learn how to classify triangles. So this first one, we're going to classify by sides. That is your first blank. Classification by sides. You're going to look to see how many sides are congruent and then make a classification by that. So how many sides are congruent on our first picture? 3 congruent sides, which I believe is a blank underneath, right? 3 congruent sides. We call this equilateral. This is an equilateral triangle. Equilateral. How many sides are congruent on our second triangle? 2. So this is called isosceles. Isosceles. This is the hardest word for people to remember. I don't have a cute way to remember it. It's got 2 S's. Actually, it's got 3. That's not helpful. It's got 2 E's. That's all I got. Isosceles. And then the last, how many congruent sides does it have? None, which we call scaling. Scaling. So triangles are special, hence why they get a whole chapter to themselves. And you'll see blanks below. It says blank congruent sides means blank congruent angles. So here's what you're going to write. When you have 3 congruent sides, you have 3 congruent angles. So when you have 3 congruent sides, you have 3 congruent angles. Which means if you have 2 congruent sides, you have 2 congruent angles. And if you have no congruent sides, then you have no congruent angles. And vice versa. Triangles are the most special shape in the world. And that's that. You can classify them by sides, and then you will also classify them by angles. I believe that is a blank. Classification by angles. There are 4 classifications. 3 out of 4 of them, you look at the largest angle. So 3 out of 4 of them, you look at the largest angle. You'll see why one of them you don't. But so looking at this first triangle, the largest angle looks to be this one, and it is less than 90 degrees. So what do we call any angle that is less than 90? Acute. So if the biggest angle is acute, we would call it an acute triangle. So acute triangle. Acute triangle. This second one is the exception to what I said. Look at the biggest angle. What do we notice about this triangle that's different than the others? They're all congruent. So, if they're all congruent, we call this something special. So, if all of the sides are equal, that's equilateral. If all of the angles are equal, that is equiangular. Equiangular. And then what you want to know is that if you have 3 congruent sides, that means you have 3 congruent angles. So if you want to go ahead and highlight equiangular and then above equilateral, these two go hand in hand because if you have 3 congruent sides, you have 3 congruent angles. So anytime you have an equilateral triangle, it is also equiangular. It's going to be both at the same time. Equiangular is the only one we don't look at the largest angle, and here is why. Does anybody remember what the angles inside of a triangle add up to? 180, right? And if all 3 of these are the same, I can split 180 degrees evenly between 3 angles. What would each angle equal? 60. So technically it is also an acute triangle because the biggest angle is acute. But in most specific, it is equiangular, which means it will also be equilateral. All right. This next triangle, what is the largest angle? The 90-degree angle, which we call a right. So this is a right triangle. When your biggest angle is a right angle, that is a right triangle. And then the last triangle. The biggest angle looks to be this one. And what kind of angle is obtuse? Which means this would be an obtuse triangle. If the largest angle is obtuse, then the whole triangle is obtuse. Those are all the words. All right. We're going to use it below. It says classify each triangle, be as specific as possible. That means classify by both angles and sides. We can do either one first. You can read the description, or you can just look at, the picture. What is the largest angle in this picture? 90, right? So we would call that a right triangle, right? So right, don't use the word triangle yet, because we're going to classify by the sides as well. How many sides are congruent? 2 of them, which means it is right isosceles. And then you could write triangle. It actually doesn't matter if you say right isosceles or isosceles right. It doesn't matter. It's the same thing. So right isosceles, isosceles right, you're good to go. Letter B, what's the largest angle? 130, which means it is obtuse. And then it is scalene, because it even says it up here. There are no congruent sides, but there are also no sides marked congruent. So it is obtuse scalene triangle. On the next page, we can classify by the angles. So we've got 60 is the largest, but they're all 60. So that means it's what? It is, because of the angles, it's equiangular. But if it is equiangular, bless you, that means it is also equilateral, because all of the sides are the same length. All the sides are 8.6. And then if you want to be the most specific, you would also say the largest angle is 60, which means that it is acute. So that is the most specific that you can be. It's acute, it is equiangular, and it is also equilateral. We're going to move to the bottom one here, and then you're going to try the other ones on your own. Classify by the angles. The largest angle is down here. What kind of angle is that? Obtuse. How many sides are congruent? 2 of them, which makes it isosceles. You can go ahead and classify the next 2, and we'll check them. So our top triangle, the largest angle is 79, which means this is acute. And then all of the angles are different and all of the sides are different, which means it is scalene. So acute scalene triangle. And then the last one, we've got the largest angle is a right angle. And then how many sides are congruent? 2 of them. So right isosceles. That's it. Questions on classifying? Wonderful. We're going to talk about interior and exterior angles in a triangle. You're not going to write down this whole definition just because it's a lot. But here's what I do want you to write down. When the sides of a triangle are extended, the interior angles are the 3 original angles. So the interior are the 3 original angles. Yep. So the 3 original angles. And I'll show you a picture. So the 3 original angles. So it says when the sides are extended, meaning you see these arrows. There's still a triangle in the middle, but there are angles created outside of the triangle, which we'll talk about in a minute with exterior. But the interior are still on the inside. All right, but the exterior, so I'm just going to read and then I'll tell you what to write. When the sides of a triangle are extended, the exterior angles are the 3 angles adjacent to the interior. So they are adjacent to the interior. So they are adjacent to the interior. And you see them highlighted here on my blue triangle. They're on the outside. And adjacent means they share a wall with the interior. All right? They're not only adjacent, what relationship do the interior and exterior have? They're a linear pair, right? So just looking at the picture, they sit on a straight line together. You know, they're a linear pair, which we'll talk about here in a minute. So we're going to focus on the interior first and the exterior second. The sum of the measures of the interior angles of a triangle. So sum means when you add them all together, the interior angles add up to 180. So what is your blank? Twice. 180. So that means angle A plus angle B plus angle C is 180 degrees. So in our example, we're going to solve for the missing angle and then classify the triangle. You can do a lot of this in your head, but I'm going to show you really what we're doing. You're going to add the question mark plus 55 plus 70, and they will equal 180. So a lot of people don't necessarily write this out. You can if you want. A lot of people just add. Bless you. What is 55 plus 70? 125. And then what do they do with that? Subtract from 180. Which means our question mark is 55. We are going to classify this triangle, so we know this angle is 55 degrees. So what is the largest angle in this triangle? 70, which means it is acute. And then we don't know anything about the angle measures, but we do know some things, we don't know anything about the side lengths, but we do know angle measures, right? How many angles are congruent? 2, which means how many sides are congruent? 2, which means that this is isosceles. So even though we don't know the lengths, we know 2 of the angles are congruent, which means 2 of the sides are congruent. When you're ready, we can turn the page. We're going to solve for x. These are all angles inside of a triangle. Again, we know the angles in a triangle add up to 180. So we could say 55 plus 54 plus x plus 74 equals 180. We can talk about a second method here in a second. We're going to combine like terms. So add all the numbers. You got 55, 54, and 74. Yeah, it's 183. Did someone say that? Okay, sorry, you're quiet. 183 plus x equals 180. Last step, subtract 183. So x is going to be negative, which is fine. What cannot be negative? The angle. The angle can't be negative. And you could always check by plugging it in. You know, minus 3 plus 74 is 71. And all 3 of these angles, 71, 55, and 54, should add up to 180. And they do. Oops. So, It's a way to check if you would like. But x equals -3 was the answer. Does anybody know option 2 in a problem that's like this? How to set it up? You don't have to do this method. Well, we know this is 54 and this is 55, right? So we can find out what this angle equals individually and then set it equal to that. So you could add 54 and 55, which makes 108, right? 109, sorry. And then subtract that from 180. This angle had to equal 71, right? This angle. Then you can subtract 74. You'd still get -3. So both options are available. So you're going to try the second, and then we will check it. I just checked your math. You had 100 and 100. Good. All right, so when you add them up, set them equal to 180, what do we get for x? We get 6. So x equals 6. Perfect. We're going to do the first question today, and we'll do the other one tomorrow. So in this one, we're going to find the measure of angle A. So we're going to take it one more step. We're not just finding x. We're going to end up finding the angle. But either way, we have 3 angles in a triangle. We know they add up and equal 180. So we can take 84 plus x plus 59 plus x plus 51, and they equal 180. Combine like terms, 84, 59, and 51. 194. All right, and then combine x and x, which makes 2x. Subtract 194 on both sides. 180 minus 194 is negative 14. Divided by 2, and x is negative 7. So we're not going to circle that. That was not what we wanted to find. We want to find the measure of angle A. So negative 7 plus 51 means the measure of angle A is 44. Good. We'll do the second one eventually, like tomorrow, but we are going to move on for today. Do we have any questions so far? Wonderful. All right, so I'd put a star next to this. You're going to see this word problem on your quiz, on your test, on your midterm. You're going to see it over and over again. The numbers will change, but the question is still the same. So the measure of one acute angle of a right triangle. So let's go ahead and draw a right triangle. Because pictures help. Whew. Thank you. So let's just pause for a second. It says the measure of one acute angle. So here's why it's saying that. How many degrees are in a triangle in general? 180. How much is taken up by the right angle? 90. So that means what's left for these two has to be, they have to add up to 90. So in order for them to add up to 90, they both have to be less than 90. So that's why they're referring to these two. I highlighted them in red. They are going to be acute. They are not, my first arrow was like, aren't they going to be 45? They're not. Did they tell us that this was isosceles? No. So you can't assume the number 45 whenever you see a right triangle. I'm just letting you know. But what we do know is that the measure of one of the acute angles, we're just going to pick one. I'm going to say this one is the one we're talking about. The measure of one of them is 12 more than 3 times the measure of the other acute angle. So we're going to break that down. So we got 12. What does more than mean? Yes, what mathematical action is happening? Adding, right? 12 more than. Then it says 3 times, all right? 3 times would be multiplication, right? But 3 times what? It's 3 times the measure of the other acute angle. Do we know the other acute angle? No. So what can we call the other acute angle? X. So we're going to say the other acute angle, we're going to call that X. So if you want to note that for a second, I won't move on yet. We're going to call the other acute angle, we're going to call that one X. So going back to our current, it is 12 more than 3 times the measure of the other acute angle. So 12 more than we got, but we want 3 times the other acute angle. So 3 times the other acute angle will look like 3x. Because it is 3 times the other acute angle. So right now I've labeled a right angle. I've labeled 12 more than 3 times the other acute angle. What do we call the other angle? X. Most common mistake is that people forget to label this third angle. It is X. It is the other acute angle. After this, what do we know about 3 angles in a triangle? They add up to 180. So we're going to take 90. That is one of our angles. Plus 12 plus 3x. That is our second angle. And then our third angle is x. And they equal 180. Combine some like terms. We got 90 plus 12, which is 102. And then we've got 3x plus x, which makes 4x. Subtract 102. 4x equals, it is 78. And divide by 4. If you're looking at it questioning if you can get a half, you can. What do we get? 19 and a half. 19.5 degrees. So here's how you can check. If you're questioning whether or not that's right, we could plug it into the other, which we have to. It says find the measure of each acute angle. So we found one of them. We need to plug it in to find the other. So you could say 12 plus 3. The other acute angle was x, which is 19 and a half. All right, we found it to be. All right, so what is 3 times 19 and a half? 58.5. Add it to 12 and we get 70.5 degrees. So what is a way I can check that all of this is correct? Add them. What is 70 and a half plus 19 and a half? 90. And then plus 90 is 180. So you're correct. These two acute angles should always add up to 90. It's actually a property in your book. We just don't learn it because, I don't make you memorize it because you should just know. There's 90 degrees left. These two will add up to 90.
So the 70 times for the x.
The 19.5 is x. This is the measure of the other angle. The other one was 12 more than 3 times the other angle. So 3 times the angle was 58.5. It's 12 more than that. That's where the 70.5 come from. Yes, ma'am.
So 12 plus 3x
Is one angle. Yes, ma'am. Any other questions from this one? Okay. We're going to learn one more new thing, and then we are finished for the day. We're going to skip the problem at the top of the next page and work on this. It's called the exterior angle sum theorem. You'll find this. I want you to take your highlighter and highlight what I highlight. The measure of an exterior angle is equal to the sum of the measures of the two non-adjacent interior angles. I'm going to break it down for you, obviously, and then I'm going to show you with what you already know. So first of all, which of these is the exterior angle? Angle 1 is the exterior angle, right? It is equal to the sum of the two non-adjacent interior angles. So non-adjacent means they don't share a wall. So what are the two inside angles that do not share a wall with angle 1? A and B. So the measure, which is your blank, of angle A plus the measure of angle B will give you the measure of angle 1. And I'm about to prove it to you. So let's pick some easy triangle numbers. So meaning don't pick the numbers 1 and 2 because then the third angle would have to be 177 degrees, which isn't, is not a thing. So what do you want? 35. All right, and then what do we want this angle to be? We'll pick 70 because we already got a 5. All right, so let's talk about what you already know. How many degrees are on the inside of a triangle? 180, right? And you've got 70 and 35, meaning of the 180, how much do you already have? 105. So that means, what is that last remaining angle? 75 degrees. Are we all okay with finding that last angle? Okay. What relationship does the interior angle have with the exterior angle? They're a linear pair, right? Which means that they are supplementary. So that means 180 minus 75, the outer angle is 105. So let's look at this property again. We just did this using knowledge we already had, right? This property is saying the two interior angles, 30 and 70, will add up and equal the exterior angle. Is that true? Is 35 plus 70 105?
No.
35 plus 70 is 105, yes. That's the property. Here's why you can't use this, why can't I just find the third angle and subtract 180? Why can't I just do that every time? Do you see this next example? There's x's. We can't do it here. We have to use the property. The two non-adjacent interior will add up and equal the exterior. All right, so which of these is our exterior angle? Which of these numbers or letters is our exterior angle? Correct. 2x minus 5. This is our exterior angle. What are our two non-adjacent interior angles? X and 70. So guess what? X plus 70 will equal 2x minus 5. So x plus 70, or 70 plus x, it's the same thing. Our two non-adjacent interior will add up and equal the exterior. So then you just algebra. Which of these is my smaller x? X. So we're going to subtract it. 70 equals x minus 5. Just add the 5, which means x is 75. Did it ask me for x? No, it asked me for JKM, right? JKM. So which angle is JKM? It's the exterior angle. It's the outside. So there are two options to find the measure. You can plug it in here. This is the least amount of thinking, I guess. You can just plug it in right there. 2 times 75 minus 5. What is 2 times 75? What's your question? We're plugging it into JKM, which is this angle. X is 75. I'm going to get there in a second. We're still on this, though. 2 times 75. 150. Minus 5 is 145. That is option 1. Okay? Option 1. You plug it in. Option 2. We know X is 75. So what is the measure of angle J? 75. And then you know J and L will add up and equal the exterior, right? These two should add up and equal the exterior. All right, what's 75 plus 70? 145. So either method is fine. Any other questions from this problem? Okay, we're going to do 2 more and then we're done. Just these 2. We'll do the other one tomorrow. Find the measure of each angle indicated. So we're going to use the property we know. What are the 2 non-adjacent interior angles? What are the letters of the 2 non-adjacent interior? U and T. So that means the question mark plus 50 will equal 120. You don't have to write it out like this. You can just math it in your head. What would I do to find the question mark? You're going to subtract, right? Subtract the 50. So what is the question mark? 70 degrees. My first class asked if they had to show the work on this. Not necessarily. It's just subtracting. When you have x's involved and you have algebra, you do need to show the work. All right, our last problem of the day. We're going to find this question mark. What are the letters of the 2 non-adjacent interior angles? S and T. So we're going to add them, and they will equal the exterior angle. So what is 25 plus 80? 105.